You are at the right place if you are looking for appropriate content in physics for JEE Advanced exam. Hi, I am Bhushan Tiwari giving you tips, tricks and concepts in physics for this particular exam. By subscribing to this channel and joining it, you are guaranteed to get hundreds of videos which are going to enrich your concepts in JEE Physics, and you can secure a very good rank by performing wonderfully well in physics. So please do join and subscribe to this channel. In today's session, we are going to take up a very old IIT JEE problem in kinematics. I have picked this question because I feel that at least first part of this question is something which might be asked in very near future in JEE Main exam. Yes, the first part of the question is very direct and it is a kind of question that can be asked any day in JEE Main exam. So this kinematics question becomes very important from the point of view of JEE Main exam also. And besides that, it gives you a very good understanding of relative motion. I have picked I basically copied the question as well as its solution from my own book, Mechanics Volume 1. Let us have a look at the question. What does the question say? On a frictionless horizontal surface assumed to be xy plane. In this diagram, the diagram is xy plane, it is a horizontal plane, it is frictionless. A small trolley A is moving along a straight line parallel to y-axis with a constant velocity of root 3 minus 1 meter per second. There is a small object, a trolley, that is traveling parallel to y-axis in xy plane without friction with a constant velocity of root 3 minus 1 meter per second. At a particular instant, when line OA makes an angle of 45 degree with x-axis, a ball is thrown along the surface from the origin O. The trolley is traveling along in the direction of y-axis. It is parallel to y-axis, the direction of motion. It is moving with a constant speed of root 3 minus 1 meter per second. At the instant when position vector of the trolley makes an angle of 45 degree with x-axis, when this line OA is inclined at 45 degree to x-axis, at that instant someone standing here rolls a ball along the floor. Now the floor is frictionless, so actually it is not a rolling motion problem. The ball will keep traveling with constant velocity only, right? So somebody throws a ball along the floor. You just roll it along the floor. There is no friction. So the ball will keep traveling with constant velocity. And the velocity of the ball makes an angle phi with x-axis. जब आपने ball को फेंका, at that instant the velocity of the ball makes an angle of phi with x-axis. And the question says, and the ball hits the trolley subsequently. Subsequently, it was found that ball hits the trolley, right? Now, based on this, you have to answer two questions. The motion of the ball is observed from the reference frame of the trolley. Calculate the angle theta made by the velocity vector of the ball with x-axis in this frame. In the reference frame of the trolley, what is the direction of velocity of the ball in reference frame of the trolley? That is the first question. And the second question is, find the speed of the ball with respect to ground, with respect to surface, if it is given that angle phi is 4 theta by 3. If you have not tried this question earlier, please take a snapshot and give it a try. I am getting out of the screen, capture it properly, and I hope that you will be able to solve it. The question is pretty straightforward, but particularly the way that angle phi has been given 4 theta by 3 makes it a bit confusing, though it is not. It is a very straightforward question. The first thing that you need to understand is that in the reference frame of the trolley, when the observer is located in the trolley, for that particular observer, trolley itself is not moving, right? We all are sitting on this huge ball, Earth, which is moving in space at thousands and thousands of kilometers per second, at a speed of thousands and thousands of kilometers per second. But do you feel that speed? No. We always find that everything The earth is at rest, everything around us is also at rest. So somebody who is located on trolley will not see the trolley to be moving. Okay, let us go to the solution given in the book. The book is Mechanics Volume 1, written by me, and this is how the solution has been explained in the book. किसी ने मुझसे कहा कि सर आप अपने बुक का बहुत प्रचार कर रहे हो। तो मैंने उससे कहा गलत क्या है, मेरी बुक है, मैं प्रचार नहीं करूँगा तो कौन करेगा। एक दिन मैंने अपने पड़ोसी को कहा था कि भाई आप प्रचार करेंगे क्या, उन्होंने मना कर दिया। मुझे ही करना पड़ेगा ना, मुझे तो बताना पड़ेगा लोगों को कि ये बुक है, तब तो लोग उसे जानेंगे, तब तो उसे देखेंगे। व्हाट्स रॉन्ग इन दैट? ओके, लेट अस कम बैक टू द बिजनेस. An observer in the trolley, this is what the book says. An observer in the trolley finds that trolley is at rest. I hope you agree to this. To the observer, the ball must appear to be coming directly towards the trolley for a hit to take place. You are in traffic, you are riding a scooter, you are really afraid if you see someone who is directly approaching you. The velocity of some other object, some motorcycle or car, is directed towards you, you must get afraid. There is going to be a hit, isn't it? So when the question says that the ball hits the trolley, so somebody sitting inside the trolley will definitely find that ball is directly approaching the trolley. The direction of motion of the ball in the reference frame of the trolley is along OA. When the trolley is at A, the ball was thrown. And the question says that the ball hits the trolley. Ball hits the trolley is the key phrase. If the ball hits the trolley, then in the reference frame of the trolley, the ball has to travel in this direction. There is no other possibility. Ball cannot be moving in any other direction. I hope you understand this. Just a moment. In the reference frame of the trolley, the ball must be moving in this direction. Trolley is at rest in that reference frame. Ball is moving in that direction. There is a hit. In the reference frame of the ground, the scenario is pretty different. In the reference frame of the ground, this is what has happened. Trolley is here, ball is here. The ball has been projected in this direction. So the ball keeps moving along this line, trolley moves like this, and there is a collision over here. So if you record this whole thing, if you make a video of the whole event, then in the reference frame of ground, this is what you will see. The trolley is going like this, the ball is going like this, and there is a hit. If somebody is sitting inside the trolley holding a video camera and he focuses the camera on the ball, then what will he observe? उस वीडियो कैमरा में जो रिकॉर्डिंग आएगी उसको प्ले करने से क्या दिखेगा? It will simply show that ball is moving along this line and it makes a hit. It hits the trolley. So in the reference frame of the trolley, the ball must be moving in this line. And according to the question, this line OA makes an angle of 45 degree with x-axis when the ball was rolled, when the ball was thrown. So the answer to the first question is 45 degree. The ball must have been thrown in this direction in the reference frame of the trolley to make a hit. In the reference frame of the ground, the ball travels along OA dash, along this line, whereas in the reference frame of the trolley, it is moving along this line OA. So let us go back to what has been given in the book. So the question says, therefore, VBA means velocity of ball with respect to A. A is trolley. So velocity of ball relative to A, relative to trolley, must be along line OA as shown in the figure. Actual velocity of the ball makes an angle phi with x-axis and VBA makes theta with x-axis. Actual velocity of ball in reference frame of ground, the ball has been rolled in this direction and the question says that this angle is phi, and the question says that this angle phi is 4 by 3 times theta. Theta is 45 degree. So this is 60 degree. So the question actually says that in reference frame of ground, the ball has been projected, ball has been rolled making an angle of 60 degree with x-axis. Whereas in reference frame of trolley, it must be moving in a direction making an angle of 45 degree with x-axis. I hope all of you have understood this. With this information, we have to find VB. What is the information? The information is that velocity of ball in reference frame of ground makes an angle of 60 degree with x-axis, and velocity of ball in the reference frame of the trolley makes an angle of 45 degree. I know that I am being repetitive, but by doing so, I am trying to ensure that all of you do understand what is being said. In the reference frame of the trolley, ball is seen traveling along OA. Therefore, theta is 45 degree. That is answer to the first question. Value of phi is given as 4 by 3 times theta, which is 60 degree. मैंने फालतू लिख दिया इसको. Okay, anyway. So it is the same diagram. I have copied it again. Actual velocity of ball makes 60 degree with x direction. Yes, we have understood that. So if I assume that speed of the ball is Vb, then in vector notation I can write this Vb as Vb cos 60 degree I cap, Vb sin 60 degree j cap. The actual velocity of ball in reference frame of ground is Vb, Vb cos 60 I, Vb sin 60 j. This is how you can put it using unit vectors I and j. This is actual velocity of ball. What is actual velocity of trolley? This is just cos 60 is half and sin 60 is root 3 by 2. And then what is actual velocity of the trolley? The actual velocity of the trolley is root 3 minus 1 j cap, because it is given in the question that trolley is moving parallel to y axis with a speed of root 3 minus 1. So this is true velocity of ball, this is true velocity of trolley, speed of ball is Vb, right? What is velocity of ball relative to trolley? What is velocity of A relative to B? Va minus Vb. So velocity of ball relative to trolley can be written as this Vb vector minus this velocity of trolley. Velocity of ball with respect to A is Vb minus Va, and this is what we are going to do. Vb minus Va, this minus this. So many I cap, ये j है और ये j है, so this minus this j cap. So this is the velocity of ball relative to trolley, and we know that velocity of ball relative to trolley is in this direction. Velocity of ball relative to trolley is making an angle of 45 degree with x axis. This is the direction of velocity of ball relative to trolley. So this vector must be making an angle of 45 degree with x axis. When a vector is making an angle of 45 degree with x axis, it simply means the x and y component must be same. So if VBA makes 45 degree with x axis, it simply means that x and y component of this vector must be same. So here this is x component, this is y component, this is equal to this. If you write it like that and simplify it for VB, you get the speed of the ball, which turns out to be 2 meter per second. So students, I hope you have understood the concept. I think it was particularly beneficial for those of you who are in class 11th, and for all of you who have not studied kinematics and relative motion properly when you were in class 11. Keep rocking, keep studying, stay healthy. Goodbye. See you in the next video with some other gupshup or some other concept in the future. Goodbye.